In today's tutorial, we're going to be creating this particular sci-fi loop. It's going to be slightly longer than usual, but we're going to go step by step and we're going to have chapters so that you can skip to which area you are intrigued by. We'll deal with each of the layers separately, after which we'll deal with the texturing of each of the layers individually. After that, we'll do a few more additions outside geometry nodes, and then we'll have our final product. Since this is going to be a longer one, let's not spend any more time and actually start the tutorial. In our default scene, we'll bring our cursor to the junction of these two windows, click and drag to create a new window, and then we'll change this from the 3D viewport to the geometry node editor. Then we'll press this plus button to create a new geometry node tree, after which we'll zoom in, select the group input, and tap X to delete it. Now the first thing that we need to do is actually create the tunnel that we'll be using as the base, for which we'll have the roof, the sides, and the floor. So we need a hexagonal tunnel. So the easiest way to do that is searching for a curved circle, and let's directly plug that into the group output, after which to make this a hexagon, we can change the resolution down to 6. Next, we obviously need to make it much larger. So we'll change the radius to something like 5, and we want this to be on the y-axis. So we'll press Shift A and search for a transform geometry node and just plug that in after the curved circle. Next, we need to rotate it on the x-axis by 90 degrees to make it facing in the y direction. Now to actually extrude this and make this into a complete tunnel, there are a few ways in which we can do this, but the way I'm going to deal with it is by searching for a curve to mesh node, and for the profile curve, I'm going to use a curve line. So I press Shift A and search for a curve line, and then I can plug this into the profile curve. Now this doesn't look like what we want, so we have to play around with the start and end values. Remember, we need this to be on the y-axis, so we're going to change the z value to 0, and we're going to change this y value to the length of the tunnel. So I want it to be 20 meters long, so I'll type 20, and that way we get a 20-meter long tunnel. Next, the issue that we face with this is that it's shaded smooth, and I don't want it to be shaded smooth, so I can press Shift A and search for a set shade smooth node, and to shade something flat, you actually use the set shade smooth node. We plug that in over here, and we just uncheck the shade smooth, and that makes it shaded flat. So this is exactly what we want from the base cylinder. So to keep things organized, we can go ahead and select all of these nodes, press Ctrl J, go to the node tab over here and label this as the base cylinder. Now let's take this and move this very far to the side, because we need a lot of space to deal with each of these sections separately. The first section that we'll deal with is going to be the ceiling. So we need to separate out this ceiling so that whatever operations we do on it will occur only on the ceiling. So we have to first find out whether the geometry is the ceiling or not. And we can do that by using the normal vectors. Remember, the normal vector is always going to be pointing outward. So we have a normal vector for this entire face that is pointing upwards like this. And similarly, we have a vector for these faces as well that are pointing outward like this, and so on. For each of the 6 faces, we would have 6 vectors that point outward. And this is what we're going to actually use to separate out and select each one of the faces. So to get access to the normal, we can press Shift A and search for a normal node, and let's zoom in. And then we need to check if the normal is pointed in the upward direction. So to check if something's pointed in a direction that we want, we can actually use the dot product. So what the dot product does is, if you have a vector like this and you have another vector pointed in some other direction, the dot product will essentially give you this particular area, which is the shadow of the second vector on the first vector. So if it is pointed at 90 degrees, you'll get a value of 0. If it's pointed in the same direction, you'll get a value of 1. So for the dot product, we can press Shift A and search for a vector math node, and we can change this from add to dot product. Now we can plug the normal into the first value, and we are checking whether it is facing upwards in the z direction. So we have to change the vector on the z direction to 1. Now this value will be equal to 1 if it is pointed in the upward z direction. So to check that, we can search for a compare node, and we can check if it is equal to a value of 1. So we plug this into the first socket and we change the b value to 1, and this result should be true only for the top face, because the bottom face has one that's pointed downward, so that's actually going to be equal to -1. So let's check if it's the right selection. So we can search for a separate geometry node, and we can plug this result into the selection, and for the actual geometry, we'll use the output from this base cylinder. So let's take this and plug that in. Now to actually see the selection, we can plug this selection into the group output, and we see that we do not have the ceiling appearing. So that's because we're currently separating out geometry based on the points, but we need the face to be separated out. So we change this from point to face, and now we have just this roof that's present over here. So we can start playing around with the roof. I want this roof to have different lights added into it. So for that, we have to create some more faces so that we can add in the different materials. So let's switch on the wireframe view and see that there's only one single face. Let's create more faces by searching for a subdivide mesh node and plugging that in after the separate geometry. And now we can actually inset each of these faces and give the insetted face the lights material. So to inset in geometry nodes, you can search for an extrude mesh node and extrude it by a value of 0. Let's change the offset scale to 0. Make sure that individual is checked, and then you can search for a scale elements node. Now we want this scale elements to scale only the new faces that were created with this extrude mesh node. So we have to take this top and plug that into the selection. Now if we change the scale down, we can slowly get the different panels that we were trying to create. So I'll reduce this to maybe a value of 0.45. Next, I want these to be even thinner on the x-axis. So I'll search for another scale elements node, or I can select the scale elements and press Shift D and plug it in over here. And this time, again, I'm going to take this top selection and plug that into the selection. And I'm going to change this from uniform to single axis and make sure that only the x-axis is selected. Then I don't want it to be this thin either. So I'm going to increase the scale to something like 0.6. And these faces that we've created are what's going to have our light material. So for that, we can set the ceiling as a single material and then set these as a separate material. So let's search for a set material node, plug that in over here, and we'll duplicate it by pressing Shift D and plugging the second version over here. Now we need the two materials. So let's go to the material panel over here, change the name of this material to roof or ceiling, and we'll press this plus button to create a new slot and give it a new material, and we'll name this one as lights. Now we'll select the roof material from here, and here we'll select the lights material. But for the selection, we have to choose this top so that only the right faces get the lights material. So let's plug that into the selection. And now we should have this section for the roof completed. So let's select all of these, press Ctrl J and label this off as roof. Next, we can switch off wireframe view again by going to solid view, and we'll deal with the materials later on. But for now, this is it for the roof. Let's move it much higher and then start off with the actual sides. Now the sides, if we remember from the base material, let's just plug that in. You see there are two types of sides. There's ones that are on top and there's ones that are down over here. We need separate effects to occur on each of them. So the top is going to have some type of crisscross pattern for ventilation maybe, and the bottom is just going to have these slabs as such. So we have to separate out each of these by themselves. So let's start by separating out the top faces. So again, we're going to use a similar method that we used over here by using the dot product and comparing the normals with some values that we want. So we have to figure out what values we want. So let's first press Shift and search for a normal node. And then let's press Shift and search for a dot product, which is a vector math node. And we have to change it from add to dot product. Next, we can plug the normal into the vector. And essentially, if we have a vector that's pointed in this direction, it's going towards the positive x-axis. So this might not have a value of 1 because it is not perfectly parallel to the x-axis, but it is somewhat tilted towards the x-axis. So we will have a value that's greater than 0, and just to be safe, we'll make it greater than 0.1 because we know that it's going to be greater than 0.1. So let's check with the x-axis. Let's type number 1 on the x-axis, and for the value, we have to check if it's greater than some value. So let's search for a compare node, plug this in, and we have to check if it is greater than a value of 0.1. Now let's take the exact same setup that we did over here by separating out the geometry so that we can see the right panels that we're working with. Let's shift this a bit more to the side, press Shift A, search for a separate geometry node, plug the result into the selection, and for the geometry, we'll use the same geometry from our base cylinder over here. So let's take this and plug it in. And just like last time, we don't want it to be a point, we want it to be a face, after which we can take the selection and plug this into the group output. So now when we plug it into the group output, we see that there's two faces selected, both this one as well as this one, which makes sense because even this normal should have some component in the positive x direction. So we need to make sure that it's not selecting this particular value. So for that, we need to make sure that the normal is also having some amount of positive z direction in it, because if it has a negative z value, then it's pointing downwards. So let's go ahead and do that by searching for another dot product node. This is going to be on the z axis, so we'll change the x value to 0 and the z value to 1. And let's plug this normal value into the vector, and we can search for another greater than node, or we can take this and press Shift D, and now we can plug the value into socket A. And again, we want it on the z axis and it has to be greater than 0. So this setup is perfectly fine, and this result has to be multiplied with this result because it has to be this and it also has to be this. So let's search for a Boolean math node and just plug that in over here, and then take this result and plug it into the second socket. Now we have the correct face that we want, but we don't want just this face, we also want the face that is on the other side as well. So to get that, we can check if the x-axis is not just positive, but also negative. So for that, we can just bring this to the side and add in an or condition, because if it is this or this, it should be selected. So let's bring this to the side, bring this to the side, and we want to check if the x value, which we're getting over here, how correlated it is to the x, is lesser than a certain value. So let's press Shift D on the greater than node, and this time we'll change it from greater than to less than, and we're going to check if it's less than minus 0.1. So that's because if we're checking it with the positive x-axis, it'll become a negative value if it's pointing towards the negative x-axis. So that's why we're going with minus 0.1. So if we plug this in here and plug this result with this particular result using an OR node, we should get what we want. So let's press Shift and search for another Boolean math, plug that in over here and change this from AND to OR, and plug this result into the OR socket. Now we have all the values that we need, so we can start manipulating these two faces. So to manipulate these, I want to again start off by giving it some type of inset, but I don't want it to just be rectangular. So to make it more complex, I'm going to search for a triangulate node and plug that in after the separate geometry. So to see what this triangulate node is doing, we can go back to wireframe view and you can see how it just added in this diagonal. If you mute the triangle node by tapping M, you can see that we initially just had two faces like this, but by adding this triangulate node, we get another face from the initial faces that we had. Next, to give it some more complexity, I just want to subdivide it once. So I'll press Shift and search for a subdivide mesh node and plug that in after the triangulate. Now that gives it this really cool look that I really like. So this is what we're gonna inset. So to inset these, we can do the exact same thing that we did before, which is searching for an extrude mesh node, but extruding it by an offset value of 0. After which we have to scale the faces. So let's search for a scale elements node and we'll scale it down by a value of maybe 0.65. But again, we don't want all of them to get scaled down. So we take this top selection and plug it into the selection, and this way we get exactly what we want. However, if we go back to solid view, we don't see any difference, and that's because we want to actually delete out the faces that we just extruded. So let's press Shift and search for a delete geometry node, plug that in after this scale elements, and for the selection we'll choose the top, and all the faces have disappeared, and that's because we deleted all of the points that were involved with the faces. So we change this from points to face, and that way we get exactly what we want. Now we can give this some sort of thickness. So to give it thickness, we can use another extrude mesh node. So let's take this extrude mesh, press Shift D, plug it in right over here, and this time we'll go ahead and start giving it an offset, and you could either give it a positive offset like this, or you could give it a negative offset so that it comes inward. But remember that when you're doing this and giving it an offset scale in the negative axis, the normals were pointed outward like this and outward like that. So right now these have the inverted normals and might cause some shading issues later on. So it's best that you actually give it a positive offset itself. And to remove all of these connections that are there in between, we can just uncheck individual, and that just makes it a nice offset. And then we have to fill up these holes. So I'll press Shift A, search for a join geometry, and we have to join it with the original geometry that we had before we extruded it. But again, remember this has normals facing outward, so we need to search for a flip faces node and plug that in right here. Now I don't need it to be this fat, so I can change this offset scale to something really small, maybe 0.1 or 0.2, and that should be good enough. Next, these are still two separate faces, so to make them one single object, we can press Shift A and search for a merge by distance node and plug that in right here, and all of these overlapping points between the face that we just added in over here and joined will also get joined together and become a single face. Once you've done that, we can go ahead and give it its own material. So let's press Shift A, search for a set material node, plug that in after the merge by distance, and choose a new material. So let's go to the material slot over here, press this plus button to create a new slot, press plus to create a new material, and this one we'll call as ventilation panels, and we'll select that in the set material over here. Once we've added in the material, we can go ahead and start with the next section. But before that, let's just label all of these properly. So let's select this, press Ctrl J, label it as ventilation panels, and bring it here. And these nodes over here, we'll separate them out and give them a frame and call this as side selection. Now the reason I'm keeping this separately is because if you think about it, the two sides that are present just below this are the exact same as this, except the comparison that we did with the Z value over here should be compared with the negative Z axis. And that way you get the bottom two faces instead of the top two faces. So we're just going to reuse this exact setup. So we'll continue in this particular region. And in fact, instead of comparing it with a negative Z value, we can also check, just as we did over here, we can compare it with a negative value. So let's go ahead and bring this dot product right here and press Shift A and search for another compare node. And instead of comparing it as greater than, we'll change it to less than and make it less than a value of minus 0.1. And then plug this value into socket A. Now we need this value to be true and we need the original sides value to be true. So we'll take the output of this section over here and plug that into another AND socket. So let's take this AND node, press Shift D, bring it down here, take the output from here and plug it into the first socket and the result into the second socket over here. Now this should give us the bottom two faces. So let's go ahead and search for a separate geometry node. And for the selection of the separate geometry, we can go ahead and use this that we just created. As usual, we need to change this from point to face, and we can take the original geometry from the base cylinder and plug that into the geometry of the separate geometry. To see it, we can take the selection and plug it into the group output. Now we clearly have the right faces selected, but now we have to go ahead and make changes to this. So I want this to look like a lot of panels are present. So the way I'm going to do that is by extruding it again by random values. So to extrude this, if we go back to our wireframe view, there's only one face, so only one extrusion will occur. I want there to be many small faces, so I'll press Shift A and search for a subdivide mesh node, plug it in here and increase the levels to something like 6 so that we get many of these small faces. And now I can go ahead and just extrude this, so I'll press Shift A and search for an extrude mesh node, plug that in after the subdivide mesh, and to see this properly we can switch off wireframe view again. Now there's a few problems. The first is all of them are extruding by the exact same amount and they're extruding in the wrong direction. So essentially we have to change the offset scale to something negative, but we don't want all of them to have the exact same number. So to make this random, we can use a noise texture. So we press Shift A and search for a noise texture, and we can increase the scale to something like 10 and plug the factor into the offset scale. But remember, this is again going to push it down in the opposite direction. So we can search for a math node and we can change it from add to multiply, and we can multiply it by a negative number. So let's go with minus 0.5, and that way they get pushed in the negative direction. But I also feel like they have far too much of a thickness. So to remove this thickness initially, I'm going to actually search for another math node and I'll change it from add to power. And this way, by giving it a large exponent, we actually reduce the thickness while keeping the differences in heights. So I'm going to make the exponent something really high, maybe go with something like 5. And that keeps these nice differences, but also makes it much thinner towards the base. So after that, we can set material for these base panels as well. So let's press Shift A, search for a set material, plug that in after the extrude mesh, and go ahead and add in a new material slot. Press new to add in a new material. And this time we'll call this as base sides. And as usual, we can select all of these, press Ctrl J and label it as base sides. Once you're done with that, we can start off with the actual floor. So for the floor, just as we've been doing so long, we'll press Shift A and search for a separate geometry, and we can plug this output from the base cylinder into the input of the base geometry, and we have to change this from point to face. And for the actual comparison, it's going to be the exact same as the ceiling, except in the negative Z direction. So that's very simple to do. We press Shift A, search for a position node, and we search for a vector math node set to dot product. So we have to change this from add to dot product, plug the position into the first socket, and we need it in the negative Z direction. So we type -1 this time, and we need to check if it's equal. So let's press Shift A and search for a compare node. We're going to keep it at equal to, and then we can plug this into the first socket. Second socket, we can keep it at 1 and plug the result into the selection. And this selection can go into the group output. So once we do this, and everything disappeared, so we need to figure out where we're going wrong. And if you actually look at this, we used a position node instead of a normal node. So let's tap X, press Shift A and search for a normal node and plug the normal into the first vector. Now we should have only the floor plane, which is exactly what we wanted, and we can start dealing with it. Now for this plane, we want there to be some cubes that are present, rotated randomly about the z-axis all around this particular plane. So for that, we can distribute some points about the plane. So let's press Shift A and search for a distribute points on faces node and plug that in after the separate geometry. But we don't want just these points. We want the original floor to also be there. So let's press Shift A and search for a join geometry and plug that in over here, and take the original separate geometry and plug that into the join geometry as well. So now we have the plane and these points. Now the problem with this is that if we were to even reduce the density, there's no guarantee that we won't have a point too close to the edge. And if there's a point too close to the edge, those side panels that we have, the cube will intersect with the side panel. So I don't want there to be anything towards the edge. So I'll go ahead and press Shift A and search for a scale elements node, plug that in before the distribute points on faces. And I just want it to be scaled down on the x-axis. So I'll change this from uniform to single axis, make sure that the axis is the x-axis, and I'll scale it down to something like 0.67. Now that way it's come more towards the center. And now I can go ahead and play around with the distribute points on faces to make sure that there are very few points and no point is too close to each other. So to make sure that no points are too close to each other, we can change this from random to Poisson disk, and we can increase the distance min factor. So we'll change the distance min to maybe something like 3 meters. And that way you see we just have a few points scattered along the face. You can always play around with the seed value to get something very random and just have fun sliding around till you get something that you like. So next, on each of these points, we need to instance a cube. So let's press Shift A and search for an instance on points node and plug that after the distribute points on faces node, and let's just bring this to the side so that we have more space to work with. And for the instance, we're going to use a cube. So let's press Shift A and search for a cube, and we can plug the mesh into the instance. Now we want this cube to be scaled up randomly. So let's search for a random value node and then plug that into the scale. And we use a float instead of a vector because we want them to remain as cubes and not become cuboids, so that they're equal on all of the axes. Next, we face an issue, and that's because every single cube is being instanced exactly at the point and the origin of the cubes are at their centers. So we have each cube just being sliced in half by the plane and they're not resting on the plane. If we were to use a set position node and just set it after the instance on points node, you see we can move all of them up, but then some of them will be floating if we just get the biggest ones to be on the plane. So we have to change this offset value based on the actual size of the cubes. So we already have the size of the cubes from this random value. So we can just search for a few nodes in between to make sure that all of them lie flat on the plane. If we directly plug this into the offset, we'll see that they're going up too much and they're also moving towards the top right. And that's because we're using this value on all three of the axes. So the first thing that we have to do is remove them from all of the other axes except the z-axis. For that, we search for a combine XYZ node and plug that in just before the offset, and we make sure that this is going on the z only. That way the x and the y remain the same. Now this is clearly going up way too much, and so we need to bring this down by multiplying it by some value. So let's search for a math node, plug it in just before the combine XYZ, and start playing around with the value until you get all of them to rest on the plane. Now I'm not able to get them to rest because I have this on add. I need to change this to multiply. And now when I play around with this, it should perfectly land on the plane at some value. So it looks like 0.5 is making them perfectly land on the plane. But because they're perfectly on the plane, there's this tiny overlap and it's glitching a bit. So I'll just change the value to something slightly higher, maybe 0.05, so that they're definitely above the plane itself and they're not really intersecting with it. Next, I want to randomize the rotation as well. So let's go ahead and use another random value for the rotation. And again, I want it to rotate only on the z-axis. So I press Shift A and search for a random value and another combine XYZ node. So let's take this combine XYZ, press Shift D and bring it right here. Now I can take this value and plug it into the z so that it rotates only about the z, and plug this vector into the rotation. Now to make the randomness complete, we can change the values from minus pi to plus pi, and that gives it a total value of 2 pi, and it'll rotate at any angle whatsoever. Apart from that, I don't want any cube to be this small. So for this random value that controlled the scale, I'll change the min to maybe something like 0.5 so that none of the cubes become that small. Next, we have to set materials for these cubes as well as the base plane. So let's go ahead and bring this a bit more to the side, press Shift A and search for a set material, plug that in over here. And remember, this is for the cubes. So let's add in a new material slot, press this new button to create a new material, and we'll call this cubes, and we'll choose cubes from this set material. Next, for the actual base floor, we can go ahead and search for another set material node, plug that into the base plane that we had, and this one we're going to call floor. So let's press this plus button to create a new slot, new to add in a new material, and this time label it as floor. Next, on this set material, let's label it as floor, and we should be done. So just as before, to keep everything organized, let's select all of these. And if you have a few of them selected and you want to select more using the same method, if you just click and drag, you lose the previous selection. So a workaround to make sure that you don't lose the previous selection is by tapping B for box select, and now whatever was selected will remain selected, and you can select other nodes as well. So once you have everything selected, press Ctrl J to add in a new frame, label this as floor and boxes, and you're done with the floor as well. Now to see all of these together, we can shift this a bit more to the side, press Shift A and search for a join geometry node, plug that in right here. Hopefully you can see we just added in a joint geometry before the group output, and now we need to connect each of these into the joint geometry. If you have Node Wrangler enabled, you can just press Alt, right click, and drag between these nodes, and they all connect up very easily, and you don't have to spend too much time doing it. And that way we now have the roof, we have these panels, we have the sides, and we have the floor with the cubes. Each of them have their own materials, so we can play around with the materials later on. Next, we need to actually create some type of hexagonal separations, because most sci-fi tubes are going to have some variation of that or the other. Be sure to save your file from time to time, and once you're done saving it, you can go ahead and start off with those separators. For the separators, we can actually use this original base cylinder that we had before we actually converted it into the entire cylinder, because if we were to convert it into those hexagonal separators from this same curved circle, we would get the exact same size. So we could recreate the curved circle and the transform geometry and all of that, but since we already have that done here, we don't need to. So let's press Shift A and search for a curve to mesh, and we can use this original curve that we had from here and plug that into the curve. For the profile curve, we can use another curved circle, but we're gonna have to play around with the actual resolution and things like that. Let's initially plug this curved circle into the profile curve to see what we have. And to take a look at everything, we can take this mesh and plug it into the group output so that nothing else disturbs us as of now. Now, this is clearly not what we want. So let's start off by changing the resolution down to something like 4. And again, it's set to shade smooth. So let's set shade flat. So let's press Shift A and search for a set shade smooth node, plug it in right here and switch off the shade smooth. Now you see we have this pointed on the insides, and it's not really like a cube. It's more like a diamond that's going around the curve. We want it to be a cube going around the curve. So to make it into a cube going around the curve, we can actually search for a transform geometry node, plug it in after the curved circle, and rotate it about the z-axis by 45 degrees. And that way we make it more like a cube that's going around that particular circle. Now, of course, you could just try out different rotations or the different axes in case rotation about the z did not work for you. I'm going to also just switch on cavity so that we can see this better. And now you can see what type of shading we actually have, or what type of shape we actually have. Now, this is all right, but I actually want 2 of these to be present within that 20-meter span. So instead of duplicating this, another thing that you could do is actually just have the curve happen twice before we convert it into a mesh. So we can move this to the side, press Shift A and search for a join geometry, plug that in right here, and just join it with another transformed version. So let's press Shift A and search for a transform geometry node, and take this geometry and plug it into the input of the transform geometry, and take the output and plug it into the join geometry. Now we have to just move it on the y-axis by 10 units, which is halfway through the 20-unit loop that we're creating. So let's change the value on the y-axis to something like 10. Now that we have this created, we can actually put this into the join geometry to see what it looks like, but you'll realize there's one small issue that's still occurring. And that is that if we have this present on the floor, these cubes are going to get cut by these hexagonal separators that we just created. So it's best that we do not have this floor as well. So to delete them, what we can do is delete anything that is below a certain threshold, but it's going to be just a little bit harder than that. We'll figure out why as we start doing it. So the first thing that we'll do is search for a delete geometry node, plug that in after the set shade smooth, and that deletes everything. Now let's start telling Blender which areas to be deleted. Since we wanted it to be below a certain area, we can search for a position node, and we have to see only the z value of the position. So let's search for a separate XYZ node, take the position, plug it into the vector, and we're going to use this z value. We need to check if the z value is less than some specific value. So let's press Shift A and search for a compare node, and we're going to compare if the z value is less than some value. Only then should the stuff be deleted. Now again, we don't want all to get deleted. We want only the edges and faces to get deleted, and we don't want the point to be the one that decides whether it gets deleted. We want the edge to be the one to decide whether it gets deleted or not. That way, if an edge is present below that height, it will be deleted. So now we can start reducing this value to bring in more and more elements. And the issue that you'll face is that if these sides are to be present, automatically this top face will still be present. It's really hard to get rid of this particular top face while keeping these side edges. If you actually start reducing this slightly further, everything comes back. So if you start increasing it, as soon as the face is removed, even these sides start getting removed. And in fact, these sides are getting removed before that face gets removed at all. So we have to tell Blender not to delete it if it is a part of these sides. So for that, we can check if the X value location of these faces are greater than some particular value or less than some particular value. So let's go ahead and press Shift A and search for another compare node, and let's take the X value and plug it into socket A, and we're saying we want to delete the geometry only if the X value location is both greater than some particular amount and less than some particular amount at the same time. Because remember, if this particular point is taken, it's going to have X location value greater than some value. Let's say 0 for now. Let's just take 0. The X location is going to be only greater than 0. There's no area where the X location is less than 0. On the other hand, this particular side has a value of X always lesser than 0 and never greater than 0. Whereas our floor has regions that have areas that are greater than 0 and regions that are less than 0 as well. So we can actually use that check to make sure that it is deleted only if it has areas that are both greater than and less than. So let's press Shift A and search for another Boolean math node, and we're going to keep this at and we want to see if it is both greater than a specific number and less than a specific number. So let's press Shift D, plug it down here, take this X value, plug it into the first socket, and we'll not keep it directly at 0. We'll say maybe greater than 0.1 and less than minus 0.1. So we have to change this from greater than to less than, and we can plug this result into this AND socket. Now we need to check if this is true as well as this particular statement is also true, because if we don't check for this statement, even the top might also be deleted, but we want the top to remain. So let's take this AND value, press Shift D, plug this into the bottom socket and this into the first socket. It doesn't matter which socket you plug it into, but for the sake of it, we've plugged it in like that. And now we can take this value and plug it into the selection. And that way we should have only the bottom faces deleted, but clearly they aren't being deleted. So we have to figure out why that's happening. Right now we're checking if the value is greater than 0.1 and less than minus 0.1 at the same time. But if the faces are being calculated from the absolute center of each face, or the edge is being calculated from the center of each face, we're going to be having this center being less than 0.1 and greater than minus 0.1, but it is not greater than 0.1 and it is not less than 0.1. So we can actually just flip these two to make it work. If we change this greater than minus 0.1, then this point is greater than minus 0.1. Like the center is greater than minus 0.1. And we have to change this less than to 0.1 because the center is less than 0.1. So the center 0.1 is here. So if this is the center, this is minus 1 or minus 0.1 and this region is plus 0.1. So the center is lesser than plus 1 and it is greater than minus 0.1. That's why we have to have greater than minus and less than plus. So hopefully that made sense now, and that's how we remove just these base panels. Now that we have that, we can go ahead and assign these panels their own material, which is going to be very similar to the ceiling material that we had created, because we want there to be some lights that are present, but we don't want the lights to be present on the ceiling as well. We want it to be present only on these edges on the two sides. So let's go ahead and figure out how we can deal with that. The first thing that we have to do is make the panels. For that, we have to subdivide the mesh just like we did for the ceiling. So let's search for a subdivide mesh node, plug that in over here, switch on wireframe view so that we can actually see what we're doing. And let's remove all of the other disturbances by directly plugging this into the group output for the time being. Now, once we've subdivided the mesh once, we can see that we have 4 faces on each of these faces, which is exactly what we want. Next, to inset each of these faces, we're going to use the same mechanism, which is an extrude mesh node. Make sure individual is checked and offset scale is 0. Then we have to search for a scale elements node, plug that in after the extrude mesh. And this time we're going to change the scale down to something like 0.75. And we have to make sure that only the newly created faces are scaled down. So take the top selection and plug that into the selection. Next, again, we need to make them even thinner. So we take this scale elements node, press Shift D, plug it in here, change this from uniform to single axis, make sure that it's on the X axis, and take this top selection and plug it into the selection. Now we can scale it down by quite a bit. So let's reduce it down to 0.2. Now that did not seem to work because we're scaling it down on the X axis. We should have been scaling it down on the Y axis, because remember, these faces are present on the Y axis. That's how we can make them thinner. So let's reduce this back to 0 and change this to 1. Now we have to deal with the materials. So let's switch this back to solid view and press Shift A and search for a set material node, plug that in here, and another set material node. So Shift D, plug it in here. Now let's add in 2 material slots. Name the first material as separator panels, and we'll take the second material slot, add in a new material and call this separator lights. Now we can go ahead and choose separator panels on the first set material, and for the second material we can choose separator lights, but we need to have a selection. Now we could directly use this top selection and plug that in, but the issue with that is that we have a lot more lights that are going to be created, because if we were to actually go back to wireframe view, you can see there was extrusions that occurred even on these side faces. So these side faces would also be lit up. Let's switch off transparency so that you can see only the side faces, and you see there's an extruded face over here. So if we were just to use this top selection, even this face would be lit up, and I don't want that. I want only the faces that are towards the inside to be lit up. So for that, we can go ahead and check for the normal direction, just like we did before. We need to make sure that it is not pointed in the Y direction. It has to be pointed only on or towards the X directions and the Z directions. So if we actually look at any vector that's over here, they will have no component in the Y direction. So the Y component of these vectors are always going to be 0. So that's why instead of comparing how close it is to the Y direction, we have to compare whether it is at 90 degrees to the Y direction, and hence have a dot product value of 0. So let's press Shift A and search for a normal node, then search for a dot product node, which is a vector math node changed from add to dot product. Next, we can take this normal, plug it into the vector, and now we need to check if the dot product is equal to 0. Only then should the material be set. So we search for a compare node, make sure that the type is not greater than but is equal, and then plug this value into the first socket, and second socket we keep at 0 itself. Now we need to check if both the conditions are true, so we have to search for a Boolean math node, and we can plug that in right here, bring it down a bit, and take this result and plug it into the second socket of the AND value. Now we should have the material set for the correct regions only, which means the lights that are present on the inner faces of these separators. Of course, they will be present on the outer faces as well, but since we won't be able to see the outer faces, I'm not too worried about that. So now let's take this output and plug it into the joint geometry, and then take the output from the joint geometry and plug it into the group output. That way we now have every single one of these components perfectly fit into our scene. The last thing that I want for the scene is actually creating some type of wire or cable that goes around this scene. So for the wire, I'm going to add in a Bezier curve. So let's press Shift A and search for a curve Bezier, and I'm going to rotate it on the Z axis by 90 degrees. And just to see it, I'm going to switch on transparency and press 7 to go into my top view. Now I'll press GY and just move it up by a bit till the base lands perfectly there. And now I can press GX and just move it to the side, maybe by like 1.5 units. Next, I'll press tab to go into edit mode, take this last handle, press GY and move it till the absolute end over here so that it is in the exact same place as the handle down here. So remember, this handle is at 1.5 on the X. That means that this handle has to also be at 1.5 on the X axis so that it perfectly loops when we duplicate them. Now I can just press A to select both the handles and then go to the segments over here and click subdivide. And I'll do that multiple times so that we have many more control points so that we can change the direction of the curve really nicely. Now I want this curve to go around these boxes. So let's just select this, press G and bring it out here. Take this G, bring it out here, and play around with the rotations as well and scale them up to make them nice and smooth if you feel like it. So if you actually look at this, you can see that the curve is not nice and smooth. It's a fairly sharp curve, so you have to select it, rotate it to make it nice and smooth, and even scale it up to make it smoother. So like that, you can go ahead and just make sure that you're on the top view and move it till you get a nice smooth curve that goes all around the place. It can be fairly random, and to be fair, it doesn't have to be smooth. It's up to your preference and what you want to do with it. You can keep it towards one side specifically, or you can keep it moving between the X and the Y, but it's best to make sure that it just does not intersect with any of the cubes. We're going to be giving this as well some material, so it'll also have quite the sci-fi effect. Now, when you come towards the end, remember that this particular point that you created started off by directly going towards the left. So at the end, when you have this last vertex over here, you should try and make sure that it's also going towards the left to make this as smooth as possible. In fact, you can actually take a look at the actual rotation that you have, and you can try and make sure that it matches this sort of a rotation. So let's come here and move these around so that we can actually have this move further to the left and just have it like that. If you have regions like this, you can always scale these down to just make it nice and smooth. So it's really how you play around with these Bezier curves, and you should have a really smooth sci-fi curve created. So once you're happy with that, we can go ahead and give this some thickness. So we go to the curve properties over here. We'll increase the resolution to something like 100 so that it's very smooth. We can increase the smooth up to like 10 as well. And for the geometry, we have to expand this and we play around with the bevel. Now I'm not going to choose an object or round. I'm actually going to give it a specific profile. I'm going to increase this resolution to 32 so that it's nice and smooth. Now to give it profile, you can actually play around with the different dots that are created here. Remember, the number of dots depends on the resolution. So if you have a very low resolution, you have a low number of dots. So I'm going to keep it at 32 and play around with it. For it to actually have the thickness, we can increase the depth to something like 0.4, and that way we get thickness onto this particular cube. I think 0.4 is too much. I'm actually going to just reduce it to 0.15, and I'm also going to switch off my transparency so that it's see it as a solid block, after which I'm going to start playing around with the profile. So you can give it whatever wacky shape you feel like. So I'm going to just bring this to the side, and I'm going to just give it some sort of intrusions just like this, so that we get these really weird shapes, and then it can come back up out. And it's really up to you as to what type of a weird shape you want to create, or if at all you want it to be a weird shape. But for now, this is what I'm going with, and I think I'm going to be happy with that. If you just want some more smooth control for it, you can actually switch to aligned free handles, and that way you can just hold these handles and scale them up and move them around to make it nice and smooth if you feel like. So once you're happy with whatever shape you've created, you can just press GZ and bring it down till it rests perfectly on the plane. So let's press 1 to go into the side view, press GZ and move it up till it's just above the plane. So I think that should be good enough. And we can give this its own material as well. So let's add in a new material and call this cable. Next, to actually make this into a seamless loop, we can shift select the original geometry node cube that we had with the Bezier curve so that both of them are selected. And then we'll press Alt D to create a linked duplicate. Then we'll press Y 20 to move it on the Y axis by 20 units. Now we can just press Shift R a few more times to create more versions of this so that it'll become perfectly looping when we actually play the animation. Next, we can take our camera, press Alt G to clear location, Alt R to clear rotation, then press RX 90 to rotate it on the X axis by 90 degrees. If we press 0 to go into our camera view, this is what we have. But I'm going to go to my camera properties here, change the focal length down to something like 24, just so that it's more wide angle. And then I'm going to go to my viewport display, increase passport out all the way to 1. Then I'll press GZ and just bring it down by quite a bit. So something like this, just so that we look like we're more towards the floor. Next, we can expand our timeline by a little bit, press back to go to frame 0, remove any keyframes if present, and then press I, location, then go to frame 150, which is going to be our last frame, and then come here and press GY 20 so that it moves by 20 units, then press I, location. Now you can go ahead and set all of your animation defaults. Let's go to our output properties, change the resolution to 200% so that it's a 4K animation. Frame rate, I'm going to keep it at 60 frames per second. So I'm going to actually change the end frame to 300 to make it a 5-second long animation, which means I'm going to take this keyframe and also grab it and move it to frame number 300. After that, I'm going to change the output folder to wherever I want it to be. File format, I'm going to choose FFmpeg video, and I'm going to change the encoding from Matroska to MPEG-4, and I'm going to keep the output quality at perceptually lossless. For the output folder, you can actually label it to whatever you want it to be. And if you've labeled it with the extension, which is going to be .mp4, so you can type .mp4, you can go ahead and uncheck file extensions so that it doesn't resave the file extension. Now, if you play the animation, you'll see it starts off slow, speeds up in the middle, and then slows down towards the end again. We don't want that, so we press A to select all the keyframes, then press T, linear, and now you should get a linear loop. Now the FPS might be a little slow, so this isn't the actual speed at which your final animation will be rendered. So to see the final playback speed, you change the playback from play every frame to frame dropping. And this will give you a realistic idea of how fast your animation or your camera is going to be moving through the scene. So this seems fine for me, so I'm happy with that. So to make sure that it's looping, go to frame 300 and then just flip over to frame 0, and you should see no difference except for the last few areas to pop in. Now once we add in all of our textures, even that will be removed, so it won't make too much of a difference. But beyond that, everything else should look exactly the same, and that means you have a perfectly looping animation. Now we can start off with the texturing for every single element individually. So let's change from the geometry node editor to the shader editor, and then change our viewport to rendered so that we can actually see what we're doing. And then let's select the light and press delete, and then switch on all of our render defaults. So let's go to our render properties, switch on ambient occlusion, expand this, increase the distance to something like 10 so that we get much better ambient occlusion occurring. And then we can switch on bloom. Let's expand this as well, change the intensity down to 0.02, and we'll clamp it down at something like 4. Apart from that, the most important setting is going to be screen space reflections, so let's make sure that that is checked. Once we have all of that done, we can select our original object and start with the materials. So first we have separator lights selected by default. So let's just go ahead and deal with that. So we select the principled BSDF, press X to delete it, press Shift A and search for an emission node and plug that into the surface. Now clearly the sides have also gotten that particular material, so we have to make changes in the geometry node again for it. So let's go back to where we had it. And if we actually go to these separators, we haven't actually labeled this. So let's just go ahead and select these, press Ctrl J, call this separator. And now we see that we didn't change the value on the dot product. We want it to be on the y-axis only. So we have to make this a value of 1. So that way we're checking with the dot product on the y-axis, it has to have a value of 0. So that way even these sides get removed and we have lights only on the inner rings. So now let's change back to the shader editor. Let's go ahead and change the color to maybe a bluish color, just like that. And we'll increase the strength to something like 200. So maybe I'll actually keep these lights as a greenish color this time, and I might play around with that just before rendering, but let's keep it as a green and another color combination for this particular tutorial. Next, let's go to the material panel over here and choose the next object that there is. So now let's choose the separator panels. Now the separator panels, I don't want anything too fancy for it. I'll just make it completely metallic so that there's really nice reflections, and I'll keep the roughness as is. I'll keep the base color also just as they are. Next, for the floor, I want it to be more or less metallic. For the roughness, I'm just going to use a noise texture, and I'm going to pass it through a color ramp for better control, and I can plug the color into the factor. And let's initially start off by plugging the color directly into the roughness, and then we'll make changes accordingly. So the first thing that I want to do is increase the scale. Let's make it something like 10. Then let's bring in the black by a little bit and bring in the white by a little bit. Now, I don't want any area to be completely reflective, so I'll change this black to a value of something like 0.2, and the white also I'll change it to a value of something like 0.8 so that no area is completely non-reflective either. Then I'm going to increase the detail all the way to 15, and I'm going to change the roughness to something like 0.8, and I think I'll leave it just like that for now. As usual, I might play around with this a bit just before rendering. The next thing that I want to deal with is the cubes. So the cubes are going to get some sci-fi material. So let's press Shift A and search for a Voronoi texture, which is by default the most sci-fi texture there is. I'll increase the metallic all the way to 1 so that they're completely metallic, and the roughness I'll make it completely 0 so that they're very reflective. And I'm going to use this Voronoi texture to give it some sort of emission as well as control some type of bump to it. So let's go ahead and change this from F1 to F2, and I'll change this from Euclidean to Chebyshev. Now if I press Shift A and search for a color ramp node, I can plug the distance into the factor of the color ramp, and then I can plug this color into the emission. Next, I'll just bring this black in quite a bit, and then I'll bring the white in by just about that much, and I'll change this white to the same greenish color that we have this green alien looking cube. Now, since we have this screen space reflections and everything going on, I can go to the world and just make this all the way to black as well so that we can see what the final objects are going to look like and how much light they're actually going to be giving out. So I think what I'll do is I'll reduce this green's value to something fairly low, and I'll increase the emission strength to something like 100. And now I can go ahead and just play around with this a little bit more. So let's actually bring the black in by quite a bit and add in another stop by control clicking, of course with the node wrangler switched on, and making this a complete black as well so that we have black on both the edges and we just have this green in the center. But again, I don't want there to be just a green. So to play around with it even more, I'm going to control click over here and make this a complete white color. So I'll change the saturation down to 0 and maybe reduce the value even more. And maybe instead of keeping the white at the center, I'll change the white to this edge, and I'll control click here and make this value all the way to 0 as well. So it's just playing around with this in different ways until you get some variation that you actually like. Maybe I'll increase the white to a complete white as well. So it's really up to you, but I'll go ahead with this for now. I might change it later on. Next, we'll play around with the bump. So I'll press Shift A and search for a bump node. And I just want a black and white color map of this Voronoi texture itself. So I press Shift A and search for a color ramp. And then I'll plug the distance into the factor and the color from the color ramp into the height. But I'll change this from linear to constant, and I'll bring this value in. And maybe instead of constant, I'll have it at linear itself, but I'll bring the black in as well. Then I'll take this normal and plug it into the normal to see a little bit of bump. Now it might be very hard to tell at the moment, but let's add in some more lights to start seeing things even better. So let's go back to the material properties, go up, and this time I'll choose the lights from the roof so that we get much more light adding in everywhere. So let's tap X, press Shift A, search for an emission node, plug the emission into the surface, and I'll increase the strength to something like 200. And I'm not going to make this white. I'm going to make it maybe blue or maybe orange. So it depends on what type of combination you want. You could go with a green yellow combination, a green blue combination. So maybe I'll go with this green and this blue. Let's increase the strength to 400. And now this is what we have. Let's switch off overlays so that we can see everything much better. Next, I have to actually play around with the roof material. So let's go ahead and just make it much more metallic so that it reflects quite a bit, and I'll reduce the roughness down to 0.3, and I won't play around too much with the roof material. Next, for the ventilation panels, I'm going to again make them metallic so that they're more reflective, but I'm also going to increase the roughness for these to maybe 0.6 or something like that. Similarly, for the base sides, which are these tile materials, I'm going to keep the metallic value at 0, and I'll just change the roughness down to 0.3 so that they're a bit more reflective. So like that, you can actually just give very simple materials to all of these so that you don't overdo the scene and it doesn't become too noisy with different elements present. Then we'll switch from object to world and we'll just go ahead and give it some volume so that the ends cannot be seen and the loop actually seems seamless. So let's press Shift A and search for a volume scatter node. Let's change this color to a complete bright white. And if we were to directly plug this volume into the volume of the world output, everything becomes much darker. Even if you reduce the density down to 0.1 or something, everything just becomes dark. To prevent this, we need areas nearby the camera to have almost no volume at all. And we can do that using a gradient texture and plugging that into the density. Now we need much more control for the gradient texture. Otherwise, we're just going to have it from left to right, just like this. So let's press Ctrl T with the node wrangler switched on to get the texture coordinate and mapping nodes. You can add these in individually as well. And this time I'm just going to rotate it about the Z axis by 90 degrees. And now it's going to be rotated such that there is black somewhere and white somewhere. But we can just bring that into the camera's perspective by moving it on the X axis. So you can clearly see how as we move, regions near the camera are becoming completely filled with volume, but regions far away still remain without that volume effect. So evidently we rotated it in the wrong axis. So we have to make it from 90 to minus 90. And now if we push the location on the X axis to a negative number, we should have regions near the camera without any type of volume and regions away from the camera having complete volume. Now, if you want this fall off to be much more gradual, you can actually change the scale on the X axis to something really small. So let's go with 0.2 and that should just scale it on the X axis. But if you're not seeing any difference, play around with the other axes as well. So let's try the Y axis. Let's go with 0.2 and that seemed to completely remove it. So let's play around with the location on the X and yes, it does come back. So let's go with a value of minus 15 and that should be all right. Now to make sure that it is enough, go to frame 300 and frame 0 and you should not be able to see anything up here. So we're clearly able to see things up here. So let's change the location from minus 15 to minus 10 and now play between frame 300 and 0 and you're able to see this difference, and that's because we're not moving away as the camera moves away. So we're actually going towards the darkness. So to fix that, we changed the texture coordinate from generated to object, and for the object we can just choose the camera. Now the actual volume moves away as the camera moves away as well. And now between 0 and 300 we can take a look, and we might have to play around with the location and the rotations and things like that, because now we're using the camera coordinates and not the generated coordinates. In this case, I think the Z value was the wrong rotation. So yes, we had to rotate it on the Y axis by minus 90 degrees and then push it on the X and scale it on the Z, after which we can play around with the X location to bring it in and bring it out. I'll go with the value of minus 20. And now if I zoom in and go to frame 0, I see no difference. So you can see the last thing that we see are these lines over here. If we go to frame 0 also, that's the last thing that we see, which means we will have a perfectly seamless looping animation when we actually render this out. So with that, if you want, you can go ahead and go to your render properties, go down to the bottom color management and play with the view transform and the look. You can actually add in some contrast and things like that based on your preferences. But essentially, that's all there is for this particular animation. Once you're done with that, you can always press render animation. For the cubes material, if you want some type of material like this, I guess these are the values that I went with. So if you take a look, it's the same Voronoi texture. Scale is at 5, randomness is at 1. I have it at F2 Chebyshev itself. We're taking the distance socket and we're plugging it through a white value initially at a position of 0.225. Then we have this blue, a value down at 0.015. The hue is the usual 0.5 that I've used. And then you can see that I just have the same blues with different values. So this is a complete black, but this has a value of 0.0001, and then we have a complete black again with a value of 0. So just by playing around with that, you can get this sort of an effect, and we've placed the same thing into the bump as well, except the color ramp is going from black to white. So that is in case you want this exact effect for the cubes. Beyond that, I also forgot to mention texturing the cable. So for the cable, it's a very simple material. We've gone ahead and made the metallic all the way to 1, after which we kept the roughness at 0.5 itself. The default 0.5 will make no difference. For the emission strength, we've increased it all the way to 1000, and that's not an issue because in the bloom settings, we've clamped it down at 4 anyway. And for the actual emission color, we've used a simple noise texture with all default values itself, and we've added in a mapping and texture coordinate nodes, and we've mapped it to a scale of 0 on the x-axis so that we get lines that go from the start to the end. Apart from that, by rotating it on the x-axis, you can get these lines to appear in different regions. So you can see at a value of 80 or 78, it comes to the sides. You can have them down there. So it's really up to you as to where you want these to be. So I'm going with a value of 34.4 just so that we have one at the top and we also have one line going at the bottom as well. If you want more lines, you can always play around with the scale of the noise texture. By increasing it, you get more lines present, and by decreasing it, you get less lines present. And apart from that, to actually make all of these go along the body, you have to make sure that you use the UV coordinates, because that's the only way you can get it to go along the curve when you're using curves. And that's actually all there is for this particular animation. If you have any questions about any of the steps or anything was unclear, definitely let me know in the comments below and I will try and answer all of them for as long as I possibly can. I upload videos every single day, so I'm sure there are videos on the channel that are waiting for you to discover and learn quite a bit. If you've watched so far, thank you so much for watching, and until the next video comes out tomorrow, keep creating and stay creative.